Mark and I are going to be talking about gradients 1 million, or actually, I think it's 4 million now, Llama 3 fine tune. What makes fine tuning something for a long context window so hard?
This is sort of like beating a dead horse, but to a certain extent, same thing that Sam Altman says all the time too, as well, right? Like the number one blocker for a lot of progress in AI is actually scale and therefore compute. So with a long context model, there's not really a way of getting around during the training process of having to have a lot of VRAM and GPUs. But once you get past that, we had a great GPU sponsor for this project. Shout out to Crusoe. They provided us an awesome cluster of L40Ss. We jumped on the opportunity to really utilize them. Outside of that, it's a lot of setting up the distributed training strategy. So that's the other aspect. And then finally, it's about curating the right data set for the model to have the best sample efficiency for learning. And we were lucky too. Like the community has been working on that. There was already a repo that was called Easy Context that provided a head start for us on that. And then for us, we migrated that repo and extended it for the specific network topology of the cluster that we were working on. So then we were able to get in and quickly just extend that context length. And I think, the community got excited. It was almost like every day we were launching a new model and seeing a lot of people try it out and adopt it.
So you talk a little bit about the one of the barriers, one of the difficulties here is that you have to be able to create a way to train these distributed in a distributed manner. How did you guys do that, and what kind of topology did you use? Like, what were your strategies for approaching that? And then the other thing is, did you have to change that as you decided to train from the 1 million to the 4 million?
Yeah, from that standpoint, we had planned. Like you always come in to everything with a specific plan, and then you work on experiments and you see what happens. I would definitely say like as we got to the 1 million, the 4 million, that started to push the limits of how we set up our network topology. I'll dive a little bit more into the specifics of like the distributed training strategy. The main components of that was one, you should probably be using flash attention because that buffers the attention that you have to keep in memory. So it turns it from quadratic to linear scaling. And then secondly, we also use ring attention. So ring attention, what that does is it kind of, if you view it as a round robining the attention mechanism across the entire set of virtual machines that you have, you're basically doing that type of network communication. And rather than having to hold everything in one virtual machine or having to have all of them have all the attention at the same time, like you're actually round robining it. Now, that comes with its own set of requirements and constraints. Oftentimes, when you're doing distributed training and you're starting to push the boundaries of how much VRAM you have, the communication, the network becomes the bottleneck. So in that fashion, we actually had to come up with a very specific way of the set of virtual machines talking to each other while they trained. So instead of going all the way this way, we actually had to break them up into different ones talking to each other and then communicating all around in like a interesting gather step. So having all that come together is like, hey, you just have to experiment. You have to run your metrics. You have to be tracking all of these things. And then finally, you have to make sure that thing's learning. Because like at the end of the day, machine learning is about learning. We're tracking the perplexity curves during that time. And all at the same time, we're sort of like, hey, we got to keep up the momentum because it kind of feels like tons of people are getting interested in this. And that's why we kind of kept going. And eventually that's why last week we released the 4 million context length model, which we're still working on. We were very transparent as it being something that will continue to progress and put at the level of the other models too.
Ring attention is interesting that you've changed the bottleneck from the RAM that you have into the network. So that's a very interesting kind of like switch there that allows you to kind of do more training, but with a different challenge or restriction. So one other thing I wanted to ask about is I think I read somewhere that this was fine-tuned for chat, and I wanted to also like learn a little bit more about this kind of difference between fine-tuning for chat versus fine-tuning for like function calling or some other sort of functionality.
Yeah. So to be clear, you kind of have to do both. So
Okay.
just like regular models are, uh, you can do continual pre-training on them to inject a little bit of knowledge. We did do effectively a curriculum learning style training. And the two data sets that we used for that were the Slim Pajamas and Ultra Chat. Different variations of it have come out online, but either way, like what it really is composing longer sequences of conversation and like the multi-turn aspects of conversation to embody the chat data set and the samples to allow your model to actually understand like, hey, it's almost like when you have whenever you talk to ChatGPT, it remembering different aspects of what you talked about in the beginning of the session and actually correlating it to what your current context is. And at the end of the day, I'll take something out of attention, but it's all about figuring out how you can make your model attend to different localized positions inside of an entire sequence. So if I am at index 20,000, attention is, well, at least the original self attention was just, a vector multiplied by itself, and then looking back at different parts of your context when you're at a specific step. So I think about when you train these models for longer contexts as like, how can you take the different permutations of like locations to encompass concepts that you want to communicate to a model?
I guess like so either way, the way that you think about fine tuning this is not really so much about fine tuning it for a specific type of functionality, but rather how different, let's say, uses or functionalities have to do with like the where the model has to pay attention to in its context.
Yeah, maybe I skipped over a little bit of the function calling aspect. So I think the content itself is also important to, for those that have not fine-tuned any models for function calling. A lot of it is like representing. It's almost like representing an API. So like you can have a spec for the API. Oftentimes that is a JSON spec, and it's JSON. To be clear, it's JSON because all of the data that's been passing through these models and all of the web crawls and all of that, they've been learned. So the model is just much more tuned to learning that. More recently, a lot of people have been looking at like YAML to be able to represent what a function spec is. So it's almost like if you were to want to create a web app and you go onto like Twilio and you read the APIs, like you don't actually know what the code is behind the scene. You only know like what you're getting back and then what is the function signature you give it. So you train on that and then you actually train on like, hey, this is the input going into this function. Here's an example of the output. And you can do that in multiple different variations. And then what would be interesting is effectively like an extended function calling example, right? Like you give function in the beginning and then you have other functions that the model already knows, and then you could chain like a pipeline and then give it many examples of like what the output would look like to get the model to really learn the function really well. So I think the interplay between the extend, that's why we wanted to extend the context length to prove to ourselves and prove to the community that like you can use this and it will impact all downstream use cases for language models.
What are some common use cases for long context windows, and specifically as it relates to enterprises?
I think this is something we think about all the time, and we're still doing more and more evaluations to find out undiscovered use cases. I think to start out with, since we're talking about function calling and coding, if you ever worked with GitHub Copilot, it feels like it's more of an autocomplete than it is like a true coding assistant, right? I think that's what all the hype around Devin was it just felt like very autonomous. with respect to how you would use long context, a lot of the times I find myself that the code completion suggestions or the code suggestions that are coming out with some of these copilots feel a little bit stuck because it doesn't understand why one piece of my module, my context, relates to the rest of the entire project or the repository, right? So imagine if you could drop in an entire repo into the context of model and then ask it to produce code for you. Like ask it to produce the unit tests that are necessary, the CI, the module itself. Like that takes a lot of knowledge, and obviously the model itself needs to be smart enough in terms of its reasoning capabilities. But like that's just one example for coding. And then hey, there's other examples like legal. So when you're analyzing or doing like legal analysis for like a specific case, oftentimes you want to be able to refer to previous precedent. So having to take all the previous precedent and making a model create this network of logic behind, hey, because of X, Y, Z precedents, you can see the evolution in the law. And therefore, in this case, these are the recommendations or the summarization that I would have in place. And we know that lawyers are paid by the hour. So, it's kind of something like you're going to see a lot of text come into these corpuses and in the context of the model. So long context plays a huge role in those, and we have not even truly begun to scratch the surface for those use cases either.
Yeah, that makes a lot of sense.